So these notes are working with 3 equations that have 3 variables in each equation, and you're solving for each of those variables. You'll see an x, a y, and a z in all 3 of the equations that are given to you. You have certain steps to follow, which are what you see on this page, that will help you in solving these. You're going to pick 2 of your original equations and eliminate one of those variables. The equation you're left with is going to be your new number 1. Then you'll do the last equation that you haven't worked with from the originals with one of the ones you already have and eliminate the same variable. Once you eliminate that variable, you'll be left with your new number 2 equation. You take the 2 new equations and you solve for one of those variables. So you're going to cancel out one of the other ones and solve for the one that's left. Once you get what one of the variables is equal to, plug it in or substitute it in to one of the 2 new equations. Once you do that, you'll get a second variable. At this point, you'll have 2 of the 3 variables. Because you have 2 of the 3, you will use one of the original equations that has all 3 variables in it. Plug in those 2 variables, solve for the last one. With all of these equations, or all of these ones that you're solving for, you will always write your answer as an order triple. So it's always going to be x, comma, y, comma, z. So if you want to make a note of that, go ahead and do that. Like I said, all of your answers for these will be in the form of your order triple of x, comma, y, comma, z. If we look at the first example, we have x minus 2y plus 3z is equal to 9. Negative x plus 3y plus z is equal to negative 2. And 2x minus 5y plus 5z is equal to 17. I always, for some reason, use the top 2 to start with. And then I use the bottom with one of the 2 that I already used. So if I start with the top 2, that's going to give me x minus 2y plus 3z is equal to 9. And negative x plus 3y plus z is equal to negative 2. I used these 2 to start with because my x's will eliminate themselves since they are opposites of one another. So if I just add or combine like terms, my x's cancel. I'm going to have negative 2y plus 3y, which is y. Then 3z plus z is 4z. And 9 minus 2 is 7. So that is going to be my new number 1. Next, I'm going to find my new number 2. I'm going to use the one equation that I haven't worked with yet, which is the 2x minus 5y plus 5z is equal to 17, and one of the ones that I already have worked with. I want to use the middle one since it is a negative, and it's going to cancel out my x values if I just multiply everything by a 2. So that's going to be the negative x plus 3y plus z is equal to negative 2. So like I just said, we're going to multiply the bottom by 2, so that way our x values cancel. You always want you also want the x values to cancel because that's the variable you chose to cancel out with in the first one. So we're going to choose the same exact variable that we're canceling out in the second time that we do this. So this is just going to turn into 2x minus 5y plus 5z is equal to 17, and negative 2x plus 6y plus 2z is equal to negative 4. Combine your like terms here, or add them. Your x's cancel. We're left with y plus 7z is equal to 13. So here's your new number 2. Now you're going to work with both of those new equations. So we have y plus 4z is equal to 7, and y plus 7z is equal to 13. We can just subtract these or add the opposites. So this is going to turn into addition with a negative y, a negative 7z, and a negative 13. We combine our like terms. Our y's cancel. We're left with negative 3z is equal to negative 6. Divide each side by the negative 3, and you get that z is positive 2. Now that you have what z is equal to, plug it into one of your new equations. I'm going to use your number 1, so that y plus 4 times z, which is 2, is equal to 7. 4 times 2 is 8. Oops. So y plus 8 is equal to 7. We move the 8 over. We subtract them from both sides, and we get that y is negative 1. Now, the only thing that's left to find is your x. I'm going to use one of the original equations now. I like working with a positive x, so I'm going to choose the top equation. So that x minus 2 times y, which we said is negative 1, plus 3 times z, which is 2, is equal to 9. Your negative 2 times negative 1 gives us positive 2. Your 3 times 2 is 6. We combine the 2 and the 6 to give us x plus 8 is equal to 9. You move your 8 over by subtracting it from both sides, and you get that x is equal to 1. So we have that x is equal to 1, y is equal to negative 1, and z is equal to 2. We said when we went over your instructions that you're going to put your answer in it as an ordered triple. So that means you're going to have an x, comma y, comma z in the set of parentheses. So that means that we just have 1, negative 1, 2. If we look at number 2, we're going to work with 3z plus x plus y is equal to 7. I don't like the order of that. All of my other equations are x, y, z, so I'm just going to rewrite this to be x plus y plus 3z is equal to 7. Just that way, like I said, it's in the same order as the other ones. So I'm going to work with that, with the 2x minus 4y plus z is equal to 7, and the 3x plus 5y minus 4z is equal to negative 6. We are going to work with 2 of these originals first. I'm going to do the top and the middle, just because that's normal to me. So I'm going to work with x plus y plus 3z is equal to 7, and 2x minus 4y plus z is equal to 7. In order for me to eliminate one of these variables, I'm going to eliminate my x's. I'd have to multiply the top by negative 2. This is going to give us negative 2x minus 2y minus 6z is equal to negative 14. And then I keep the 2x minus 4y plus z is equal to 7. Now that our x's are opposites, we can just add like terms. Your x's cancel. This leaves you with negative 6y minus 5z is equal to negative 7. This is your new number 1. Next, find your new number 2. You have not worked with that bottom equation yet, so work with the 3x plus 5y minus 4z is equal to negative 6. And one of the other 2. I'm going to choose the top one. So x plus y plus 3z is equal to 7. You need to eliminate your x's because you eliminated the x's from the first 2 that you worked with. So in order to do that, we can multiply the bottom by negative 3. The top is going to stay the 3x plus 5y minus 4z is equal to negative 6. The bottom turns into negative 3x minus 3y minus 9z is equal to negative 21. From here, we combine like terms. Your x values are opposites, so they cancel. You're going to be left with 2y minus 13z is equal to negative 27. This is your new number 2. So you're going to use both of these new equations to eliminate your next variable. So we just rewrite this to where we have negative 6y minus 5z is equal to negative 7, and 2y minus 13z is equal to negative 27. From here, easiest one to get rid of is the y values. They're opposites, so the only thing we're multiplying the 2 by is 3 in order to get them to be opposite coefficients. So we have the top that's not changing, so negative 6y minus 5z is equal to negative 7 is going to stay. The bottom, you're going to have 6y minus 39z is equal to negative 81. Add these or combine like terms. Your y's cancel. We're left with negative 44z is equal to negative 88. If we divide each side by that negative 44, we get that z is equal to 2. Use one of your new equations now to solve for y. I'd rather work with a 2y, so I'm going to use that one. So if I use that 2y minus 13 times z, which is 2, is equal to negative 27. I'm going to multiply my 13 by my 2 to get 2y minus 26 is equal to negative 27. We add the 26 over. We're left with 2y is equal to negative 1. Divide each side by the 2, and you have that y is negative 1/2. From here, now that you have a y and a z, find an x. If it was me, I would use the middle equation because your y is being multiplied by an even number. So 1/2 times an even number is going to cancel out that fraction, and I don't want to work with the fractions. So if I use the middle equation, we're going to have 2x minus 4 times y, which is negative 1/2, plus z, which we said is 2, is equal to 7. From here, the negative 4 times negative 1/2 gives us 2x plus 2 is equal to 7. That 2 plus 2 is 4, so 2x plus 4 is equal to 7. We move the 4 over, subtracting it from both sides. We get 2x is equal to 3. Divide each side by the 2, and you get that x is 3 over 2. So again, you are going to write your answer as an ordered triple. So your x is 3 over 2, your y is negative 1/2, and your z is 2. So as an ordered triple, you're going to have x comma y comma z. That's going to give you 3/2, negative 1/2, positive 2. We look at our next example, number 3. We have 2x plus y plus 3z is equal to 9. 2x minus 4y plus 2z is equal to 16. And negative 4x plus 3y plus 2z is equal to negative 4. If, again, I start with my top two, that means I'm going to work with the 2x plus y plus 3z is equal to 9. And the 2x minus 4y plus 2z is equal to 16. I'm going to subtract the bottom from the top, which means I'm going to change the sign on everything. So the 2 becomes negative, the 4 becomes positive, the 2z becomes negative, and the 16 becomes negative. Your 2x's are going to cancel. Your y plus 4y is 5y. 3z minus 2z is z. And 9 minus 16 is negative 7. This is your new number 1. Find your new number 2 now. If we use, let's use the top and the bottom. So 2x plus y plus 3z is equal to 9. And negative 4x plus 3y plus 2z is equal to negative 4. The top, we're going to multiply by 2 to make sure our x's are opposites of one another. So this is going to give us 4x plus 2y plus 6z is equal to 18. And negative 4x plus 3y plus 2z is equal to negative 4. Combine your like terms or add these. Your x's cancel. we're going to be left with 5y plus 8z is equal to 14. This is your new number 2. Use both of these and cancel out one of the other variables. So if we use 5y plus z is equal to negative 7, and 5y plus 8z is equal to 14, we can just subtract these two or add your opposites. Your 5y's are going to cancel. The z minus 8z is negative 7z, and negative 7 minus 14 is negative 21. We can divide each side by the negative 7, and we get that z is 3. Use this into one of the new equations. I'm going to use the first one, so that's going to give me 5y plus z, which is 3, is equal to negative 7. Move your 3 over, subtract it from both sides. That's 5y is equal to negative 10. Divide each side by the 5, and you get that y is negative 2. From here, use one of the originals. I'm going to use the top one. So that's going to give us 2x plus y, which is negative 2, plus 3z, which is 3, is equal to 9. This is going to simplify to be 2x minus 2 plus 9 is equal to 9. Your negative 2 plus 9 gives you 2x plus 7 is equal to 9. We subtract this 7 over. We're left with 2x is equal to 2. Divide each side by the 2, and x is 1. So if x is 1, y is negative 2, and z is 3, our order triple is just going to be 1, comma, negative 2, comma, 3. For your last example, it's a little different than the ones that you've done so far. So with this one, you're going to do the same exact thing that you've done with all the other 3. Use the first 2. You have x minus 3y plus z is equal to 1, and 2x minus y minus 2z is equal to 2. Cancel out one of the variables. I'd multiply the top by negative 2 to cancel out your x's. It's going to give you negative 2x plus 6y minus 2z is equal to negative 2, as well as 2x minus y minus 2z is equal to 2. We're going to add these. Your 2x's cancel. Your 6y, minus y is 5y minus 4z is equal to 0. So again, this is your new number 1. To get your new number 2, use the last and the top maybe. So if you have x minus 3y plus z is equal to 1, and x minus 2y minus 3z is equal to negative 1, you can just subtract these or add the opposites. X's cancel. You're going to be left with negative y plus 4z is equal, hold on. Is this, okay, sorry, because this was a positive to begin with, then it turns into a negative. So this is negative 5y is equal to, and then this becomes a positive 2. Okay. So from here, you're going to use now the 2 new ones. So 5y minus 4z is equal to 0, and negative 5y plus 4z is equal to 2. Combine them. Your y's cancel, your z's cancel, so that's 0. 0 plus 2 is 2. This is a false statement, so you would have no solution. in the sense that you got something that is like 2 is equal to 2. That would be a true statement. So anytime you get a true statement, your answer would be infinitely many solutions.